All right, last lesson of the week. So we're going to do algebra of matrices. When we do algebra of matrices, I kind of skipped around on this one just because I feel like this is the easier of the matrices, and then we kind of started into some other things. The big thing is you need to know order of a matrix, so that's rows by columns. And we always write this because it'll help you when you add or subtract. So like this matrix A right here, the first one, it's a 3 by 2 because I have 3 rows and 2 columns. Same way with B, it is also a 3 by 2. C is a 4 by 2, and D is a 2 by 4. All right? So when you're doing these, in order to add matrices, they have to have the exact same order. All right? So notice A and B are the exact same order, which means I can add them. So -3, 0, 11, 2, -5, -9, plus 3, 5, -10, 17, 4, and 4. So when you add matrices in the same order, you just add the numbers that are in the same spot. So you see how this -3 and this 3 are in the top left. I'm going to add those to get 0. This 2 and the 17 are in the top right. I'm going to add those to get 19. This 0 and the 5 are in the middle left, so I'm going to add those to get 5. Middle rights give me -1. Bottom lefts give me 1. Bottom rights give me -5. And that is your answer when you add matrices. And again, in order to add them, they have to have the exact same dimensions. So if you notice, 4 by 2 is C, and then a 2 by 4 is D. Those are not the same dimension / order, whatever you want to call it. So this is not possible. And that's what you would write. Not possible. And I think on Hawks, there's a button to select. Okay? This is called a scalar. So you're going to multiply every number by that number, just like the distributive property, but for matrices. That's the way I think about it. So put -4 on the outside. So you just multiply everything by -4. So I get -8. So -4 times 2, -4 times 1, -4 times 0, -4 times -7, -4 times -5, -4 times 0, -4 times 3, and -4 times 10. And that would be your answer. All right. B minus A, again, have to be the same dimensions to do adding or subtracting. They're both 3 by 2s, and the order matters. It says B first, so I've got to write B first. So 3, 5, -10, 17, 4, and 4, minus -3, 0, 11, 2, -5, -9. On the subtraction one, you've really got to watch your signs. So top left minus top right, but notice it's minus a negative, so it turns into a positive. So that turns into 3 plus 3. 17 minus 2 gives me 15. 5 minus 0 gives me 5. 4 minus a -5 turns into 4 plus 5, which is 9. -10 minus 11. And then 4 minus a -9 turns into plus, right? So I get that. Okay. Sometimes they have you do a scalar and then add. So I'm going to do A times -3. So I'm going to go ahead and write this. I'm going to multiply everything by -3. So here's my A matrix. Multiply everything by -3. So I'm going to get 9, 0, -33, -6, 15, 27. Plus, I'm going to take everything in B, that one in green. I'm going to multiply it by 2. So 6, 34, 10, 8, -20, and 8. So now you can add them. 9 plus 6 gives me 15. -6 plus 34 gives me 28. 0 plus 10 gives me 10. 15 plus 8 gives me 23. -33 plus -20 gives me -53. And then 27 plus 8 gives me 35. So you would multiply first and then add or subtract. Okay? So that would be adding on a matrix together. So now we kind of get to the tougher ones, which is multiplication. When you multiply, the order does not have to be the same, but you need the inside numbers to be the same. And I'll show you what I mean. So this one, A is a 1 by 3. B is a 3 by 2. C is a 3 by 1, and D is a 2 by 2. So I'm going to take A times B. So I'm taking a 1 by 3 times a 3 by 2. So in order to multiply, do you see how the inside numbers, kind of like the FOIL method, it's the inside, they're both 3's? That means you can actually multiply them. So this is possible. The inside numbers have to match up. And then the outside numbers are going to give you the resulting matrix. So when I multiply, I should get a 1 by 2. So I'm going to take this row times everything in this column. And you do first column. So I'm going to take 5 times negative 6 plus 2 times 4. So do you see how I took the first number times the first number and the second number times the second number plus 3 times the third number. So third number, and you add those together to get your first number. So this is negative 30 plus 8 plus 18, which is 26 plus negative 30, which should be a negative 4. All right. So that's just to get the first number. So then the second number, I would take the same row, but times the second column. So I'm going to take 5 times negative 5 plus 2 times negative 2 plus 3 times 7. So that would be negative 25 plus negative 4 plus 21, which gives you negative 8. So you see, my resulting matrix is a 1 row, 2 column matrix, which is the outside numbers, which makes sense. So I got negative 4, negative 8. BA, if we try that one, that's a 3 by 2 times a 1 by 3. Notice the inside numbers don't match up, so that is not possible. AC, you have a 1 by 3 times a 3 by 1. Numbers match up. Resulting matrix should be a 1 by 1. So when you do this, you're going to get 5, 2, and 3 times 10, negative 4, and 9. So kind of like what we did last time, we take the first row times the first column. I'm going to do 5 times 10 plus 2 times negative 4 plus 3 times 9. So that's 50 plus negative 8 plus 27. Your resulting answer is 69. And it's a 1 by 1, so it should just be one number. All right, and the last one is d squared. Now, this is a 2 by 2 times a 2 by 2 because you're doing it twice. Do not square every number inside of it. Instead, you have to do this and actually solve it like a typical matrix. So this is kind of like one of the more elevated ones. I'm going to erase this and give myself some more room. Put that over here. So I'm going to take this first row times this first column. So I'm going to take 4 times 4 plus negative 10 times 2 to get the first number. The second number is going to be the same row, but times the second column. So I'm going to do that out to the right here. You always go to the right because it's in your row. So 4 times negative 10 plus negative 10 times 1. Now I take the second row times the first column. 2 times 4 plus 1 times 2. And then lastly, you take second row times second column. So 2 times negative 10 plus 1 times 1. So when you do all that and you add it together, you should get negative 4, 10, negative 50, and negative 19. All right. So then we go into our last part, which is essentially a system of equations, guys. What I would do, some are easier than others. Like B is really easy compared to A. On A, You see how there's a scalar on the outside? So I would just write the equation. So the top equation is just the top row. So it's going to be 20x minus 60 equals negative 2y. And then if you notice, the bottom one is going to be 12 plus 4y equals 4x. That's kind of up to you how you want to solve it. I'm going to take the second equation and divide everything by 4. So I'm going to get 3 plus y equals x. So I know what x is. I'm going to take that, I'm going to sub it into the other equation. I'm going to solve it like a system. So y is 0, which means x, when I plug in y, is going to be 3. So my answer to that would be 3, 0. So it's kind of like solving a system. You just got to write it out. Now b is pretty easy because you're just taking the first part, every single one, and you're going to write an equation from that. So I'm going to get 8x minus 3x equals 30. You still have the scalar on the outside. So then like the y's, it's always the second number. So it's going to be 4y plus 3y equals negative 21. And then lastly, you have your z's, which is 12z minus 6z equals negative 42. And really what you guys can do is you can just solve it from there. So like the first one's 5x equals 30. I would divide by 5. X is 6, right? Next one's 7y equals negative 21. 12z minus 6z equals negative 42, and you solve them. So you should get y is negative 3, z is negative 7. All right? So that's my answers. It's not hard. It's just a matter of remembering how to write it. So that is adding and subtracting and multiplying. And also how do we solve it based off of if they give us a matrix with a scalar that has an x and a y in it. Okay? So that homework assignment is going to be Hawks 10.4. If you guys have any questions, please let me know.